Find the derivative of g of x equals the cubed root of x cubed divided by x cubed plus 8. So g of x here is the cubed root of an entire expression, which itself is a quotient of x cubed over x cubed plus 8, which gives us a hint of how to take the derivative. We have that overall cubed root, which I'm going to rewrite as a fractional exponent. I will leave the inside alone, and it's to the first power third root, so 1/3 power. So overall we have a 1/3 power of everything, but inside of there we have a quotient, and therefore when we do the derivative of the inside for the chain rule, it will be a quotient rule needed. So our derivative g prime of x will be, we'll start by power rule, bring down the 1/3, leave the inside alone, we have x cubed over x cubed plus 8, to the subtract 1 from the power, I will call it 3/3, so 1/3 minus 3/3. And then multiply by the derivative of the inside to complete the chain rule. Well, the inside is a quotient, so we have to follow the quotient rule here. And here's our quotient. So we're going to start with the derivative of the numerator. That will be a 3x squared times the denominator left alone, x cubed plus 8, minus the numerator left alone, x cubed, times the derivative of the denominator, which will be a 3x squared plus a 0, or just a 3x squared. And all of that is over the denominator squared. Now this entire expression here is multiplying what's next to it. Everything's multiplying. So we have a 1/3 an x cubed over an x cubed plus 8 raised to the 1 minus 3, negative 2/3 power. And what I'm going to do is start to simplify within here. I'm going to start by distributing that into there. 3x squared times x to the third, we add the exponents, so 3x to the fifth. And then a 3x squared times a positive 8 will be a 24x squared. And we have this minus, and we have an x cubed times a 3x squared, that'll be a 3x to the fifth. And then all of that is over that denominator of x cubed plus 8 quantity squared. Now in the square brackets I can combine like terms in the numerator. Actually this 3x to the fifth and this negative 3x to the fifth, those will cancel, and there's what I have left over. So g prime of x will equal, I have a 1/3. I'm now going to separate the x cubed, and it'll be to the negative 2/3 power over the x cubed plus 8, also to the negative 2/3 power. If you have a fraction raised to a power, you can raise the numerator and denominator to that same power separately. It's a good idea to do that because we'll be able to simplify in doing so. And we now have this multiplying. What's left in the square brackets, we have a 24x squared over a x cubed plus 8 raised to the power of 2. What I'm going to do though is I'm going to change that power of 2. Instead of writing as 2, I'm going to put it over a common denominator because I'm about to multiply the denominators, and see I'm going to be able to multiply these two with each other. And when you multiply like bases, you're going to add the exponents. I have a negative 2/3 exponent on the 1. I'm going to want this exponent to also be over 3. Right now it's a 2. I'm going to rewrite it as a 6 over 3. That'll make it easier to actually multiply those. Now in the numerator I have 1 times an x to the 3 to the negative 2/3 well, 1 times anything is that same thing. So x to the 3 to the negative 2/3. I also have a 24x squared. And then I have the entire thing over a 3 times an x cubed plus 8 raised to the power of, we add the exponents, so we have a negative 2 plus 6, 4 over the common denominator of 3, 4/3 power. The next thing we can do is this term right here. It's a negative exponent, but before we do anything with it, we can multiply those exponents. When you have something raised to an exponent and then raised again, you actually multiply the exponents. So that's going to be x raised to the negative 6/3, or negative 2 power. So I can write it as x to the negative 2. Now again, we have the option of putting it in the denominator, but we can actually multiply it with the x to the positive 2 power that's after the 24. Everything's multiplied in that numerator. We still have it over this denominator, but I'll just leave alone. So x to the negative 2 and x to the positive 2, we can put these together, and that'll become x to the 0. Well, x to the 0 is a 1. And therefore, they will cancel each other out to a 1. I'll just write it as x to the 0 right now. Add the exponents, because I can see one more step we'll need to do in simplifying this. So the x to the 0 is just a 1, and we'll replace that with a 1. The other thing we can do, though, is we have a 24 in the numerator and we have a 3 in the denominator. Let's cancel these down, and that will be an 8. And that x to the 0 will replace with a 1, and 8 times 1 is an 8. That should be as simple as we can write this derivative. It looks like it's going to be 8 divided by x cubed plus 8 to the 4/3 power. And there's our derivative, g prime of x.